Hello, my math champions, and welcome back to my channel. Today we're going to study how to graph absolute value function. You can take a notes. This is the topic, copy it to your notebook, and we're going to step by step analyze and learn how to graph absolute value function. In general, you will see the formula of absolute value. As you see, y equals a, absolute value x minus h, and plus k. And we're going to try to understand or learn what is the coefficients a, h, and k, and how they reflected on parent function. By the way, what is parent function? I wrote for you right here, y equals absolute value of x. And as you see, this is the simplest form of absolute value function. And in general, all other type of functions in simplest form, we will name as parent function. So next, let we graph this parent function. It's pretty easy. What we can use, we just plug in values of x and find corresponding values of y. Well, let me start with 0. If I plug in 0 here, absolute value of 0 is 0. So the first point would be right here. We plot in coordinate plane. So let me try, for example, 2. Well, absolute value of 2 equals 2. So corresponding value of y will be 2. And that's what I'm plotting. So value of y is 2. Well, let's try 3, for example. As you see, 3 for y, corresponding 3 for x, 3 for x, and corresponding y would be 3. Let me try negative numbers now. Negative 2. We know that absolute value of negative 2 equals to what? Right, positive 2. 1, 2. All right. Absolute value of negative 3 corresponding will be 3. That we have enough points. We're going to connect those points. I'm using my ruler. We're going to connect and see what will happen. So right here I put show that is continuous first. Okay, and as you see, what we have V shape. So absolute value function, when you see V shape, you can recognize what kind of function it is. And this is, we will call parent function, because that's how in beginning absolute value will look or looking. Now we're going to graph those two functions. As you see, what is different, we compare with parent function, we're just adding one, and another one we're subtracting one. So what do you think what's happened with this parent function? In first case, that value of y will be shifted 1 unit up. In second case, value of y will be shifted 2 units down. So I'm going to use that green to graph y2, and it would be absolute value of x plus 1. What does this mean? Compare with parent function, each point will be shifted for 1 unit up. So if I have that first point here, of course 0 plus 1, that would be first point. And each point on this parent function, on graph of parent function, will be shifted up by 1 unit. So I'm going to do the same here. So So when we going to connect all these dots, all right, we still have this shape. And what we noticed, what's happened with parent function, compare with parent function, this parent function shifted 1 unit up. So let me go back to this formula. That is when you're adding number to absolute value, see? Adding number. So it actually gives us translation up and down, so horizontally. Let's see the same with function y3. So that parent function, and it's shifted 2 units down. If I would, for example, so that my parent function, and each point of parent function would be shifted down by 2 units. And then when I connect all these points, you will see transformation of parent function by shifting each point by 2 units down, because that negative sign. All right, so now we're going to analyze next. So beside of vertical shifting, the graph can shift it horizontally, as we understand. And we're going to, I will write down some examples, and we will use the same graph coordinate plane to show those next transformation. The next transformation we will discuss on example of this function. So as you noticed that 5 inside, it goes with x inside of absolute value. Guys, this type, we're talking about this part of in general, it gives us horizontal shifting. So if I put x minus 5 equals to 0, then x equals 5. In other words, that parent function will shift it to the right 5 units. So each point of my parent function will shift it to the right. So this point would be 1, 2, 3, 4, 5 here. Then this point 1, 2, 3, 4, 5. It would be enough. And I take on the left side. So 1, 2, 3, 4, 5. I'm going to connect. I will use some, this maybe color. So what we will have, again, it's V shape. And we're going to compare this parent function. So we compare that kind of pink and red. As you see, it shifted 5 units to the right. So what we can analyze that this part H gives us horizontal shifting. We continue studying absolute value functions, and we are investigating effect of coefficient A, H, and K on the graph. By doing so, we're going to graph those functions I wrote down for you. You can see, and compare with parent function. The parent function I graph here, it's in black, and you can see that f of x equals x, absolute value of x. That's our parent function. Let's take a look at the first one in green. So what's different between parent function, we add that, we multiply by coefficient a, which in our formula, that a. In this case, we have 2. So in other words, each value of y, we multiplying by 2. That's why we have that more narrow graph compared with parent function. So what we just find out, that if in our case the coefficient is 2, so it is greater than 1, that's what we will compare, greater or less than 1. So in this case we have greater than 1, and the graph is narrow than absolute value of x, that parent function, when if that absolute value of a greater than 1. In this case we have 2, and that our graph, we just graph and we can investigate. So now what's happened if coefficient that is negative 2? What transformation will affect in this case? So in blue, you will see that graph. It is y equals negative 2, absolute value of x. What's happened, what we see, it is flipped over x-axis, or we name it's a reflection over x-axis. It's simply, we just flip it, right? So that's another thing what we just learned, that negative, if a is negative, we're flipping the graph over x-axis. The next one, we're going to analyze that graph, and this, in this case, the a equals 2, h equals 4, and k equals 3. What kind of transformation we will have? In this example, we can see all transformation of the absolute value function. So let's take a look. F of x equals 2, absolute value x minus 4 plus 3. So we notice that a is 2, h is equals 4, and k equals 3. So if we compare, we notice that vertex of the red graph located at point 4, 3, that is your vertex, and that the red graph is nearer than green. Because of coefficient of 2, we're talking about vertical stretch by factor of 2. Sometimes you can see those words. But what you have to understand, that is narrow or wider. And those words you will see applied on some assignments at school. You can see shrink or stretch. That pretty much we're talking about narrow or wider. In next lesson, we're going to practice how to graph absolute value of function and all transformations applied to the graphs. So let's go to next lesson.